It all has to do with raising your score on the ACT. It's not about how smart you are. It's not about what math class you're in. It's about how much you practice the ACT. Okay, so every week I'm going to give you not only the homework that kind of goes with this curriculum, but I'm also going to give you a practice test, right? Do you have to do it? No, I mean, it's not like I just, give you a grade or something, but I would recommend it. If you do a practice math session once a week, you're going to get really good at these questions, okay? Say, the one on the far left is new, yeah. Okay, so this practice ACT, and I have a ton of them. I'll provide you guys one every week, and if you ever want extras, that's fine. If you do it, I'll grade it, and I'll convert it to an ACT score for you. So you can see, like, I would have got a 32 or a 29 or whatever, okay? Now, or a 13. When I am privately tutoring somebody, or if I have, like, a small class, which I've done in the past, right? What I'll do is the first week, I'll have them do one of these untimed, okay? So untimed, just work on it so you have a chance to see every single problem, do your best on it, so you take that part of the anxiety out of it, the timing part, and you just take time to do all of it. So it were me, and I was sitting around, and I was watching, I don't know, what do you guys watch? Some, 2020 crime documentary or something. That's me, not you. If I was watching that and then I just pull this out and do a few problems at a time or whatever, that's fine. Now, as we get later on in the class, I would want you to start doing it with timed conditions, okay? Because that adds an extra element of stress to it a little bit, right? So I'd want you guys to do that more with timing, and then, so we'll do that later on, okay? And I'd have them do a few untimed, and then I'd have them do a few timed, all right? Okay, we're going to try to get through more of this than the first class did. I think we can if Delano can be quiet. And I think Delano could be quiet. What do you think, Delano?
Yeah, I'm sitting down like right
now. Boy. Okay, we ended off on charts and graphs, right? Cool. Yeah, we did our parentheses. We ended up on charts and graphs. All right? So we're on this page that says charts and graphs. We're going to see if we can make it through a bunch of these, okay? All right, so we'll go over a lot of this, see if we can get through everything. All right, that's good. Come on, why are you not connecting? In my first class, did you go to the first one last time? Oh, yeah, I don't know, did I do percents?
Yeah.
I think we did it. In my first class, I didn't get to it last time, so I did it this time. But I can go over with you too. Okay, so we're on charts and graphs. Or you can watch the end of the video. I'm going to always video the second class because I think it's better. All right. Delano, let's go. Am I right? Let's go. Okay. So, did you get one for the one you left at home? Back there? Get the one that says ACT week 1, but it's going to be ACT week 1 and week 2. All right.
It's on here.
All right, that's fine. You can just watch. Okay. So there are different types of charts and graphs that you're going to have to read. You guys, right here, here's an example of a pie chart. Here's an example of just like a table. That's pretty easy. This is called sometimes a bar graph or a histogram that you have to read. These are just examples of charts, okay? One of the most common charts we're going to look at is called scatter plots. Have you guys seen scatter plots before? Okay. Yeah, kind of. So it looks like this on the next page there. It looks like that. There's two things I need you to know about scatter plots, all right? 2 words that they will ask you. Okay. Strong correlation versus weak correlation. Okay, a strong correlation shows a very clear trend. A weak correlation shows just like a random cloud of points, all right? So a scatter plot is going to have a bunch of points and then a line through it, a best fit. The further apart the points are from that line, the weaker the correlation is. The more together they are, the stronger the correlation is. So you want to know those words. And the other words that we use to describe scatter plots are positive correlation versus negative correlation. Okay, positive correlation means when one variable increases, the other one increases. So up goes up. Negative correlation just means it goes down. All right? So if you're looking at a graph like this, would you guys describe this as strong or weak correlation? That's pretty strong. Yeah, I would say that's strong. Showing a very clear trend along that line. Is it a positive or negative? Positive. Okay? Then a lot of times it'll ask you to look at the line of best fit and make a prediction. So this one's saying, like, here's my line of best fit. What's the likely height of someone with a shoe size of 5? Well, you guys see how this, and it didn't copy great for you, and I'm sorry about that, but you see how we have this, like a line that goes through here? Okay? Well, the problem is, like, yeah, a shoe size of 5 is going to be back over here a little bit more, right? So we can kind of guess where we think it would be. Now, one thing that you can do, we were talking about this a little bit last year too, is, okay, does it look like it's going down 1 inch and over half a shoe size, right? That's what this is doing. It looks like it's going down 1 inch and over half a shoe size. So I could kind of like math up right here and be like, okay, let's see. So from here, if it goes down 1 inch and over 1 shoe size, that would be a shoe size of 6 is 5'1". And then if I go down 1 inch and over half a shoe size, 5.5 would be 5'0", right? And then if I went down 1 inch and over half a shoe size, 5 would be 4'11". So that's 4, so it's like 4'11". Now if it was multiple choice, you know, and they weren't too close together, you could probably pick that out. But I can just kind of follow my slope or whatever. Okay? Does that make sense?
Mm-hmm.
Okay. We're going to do these ones together because I think that they're a little bit, usually I'll let you guys do these, but we'll do these together real quick because I think these are a little tricky. So we're creating a plan for persistent sales chips, the company that manufactures computer chips. All right. Looking at C, so C represents cost. Okay, that's what the cost to make a computer chip is. And then R represents revenue. Okay? Okay, I want to talk to you really quickly actually about something that comes up a lot on SAT and ACT questions, and that's this. You know how lines, like lines of best fit, or we have lines of y equals mx plus b, okay? All right, what I want you to understand about a line when we're in a story problem especially, or you know, something like this, a word problem. This is something called the flat rate, okay? Sometimes it's called the starting value, something like that, all right? What that is, okay, so here's my, like, analogy. I'm ordering an Uber and maybe it's like $20 flat for the Uber to come and get me and then $1 per mile or something. You know, that's kind of how these things work. So that would be the flat rate. That would be like the $20. And then this would be like the variable rate, which is like the more miles I go, the more it costs.
Plus 1 and then X would be your miles.
Yeah, exactly. Okay, so we have this like flat rate here. But you'll also notice that this flat rate is the y-intercept and this variable rate is the slope, okay? So it says that before they began making this computer chip or whatever, there's a fixed cost for investment in research. So before they even start making it, there was a research cost, right? You guys, that's the flat fee, that's the research cost. So that's where cost is like right here. Okay, so what does that look like, what the research cost is? 27. Now this one's pretty easy because they all say 27. You just have to read it carefully in millions. So 27 million. All right. Okay, cool. Then Precision Chips maintains the same price for chips. What's the sales price per chip? This is tough, especially because you guys didn't show your grid lines on there, so I'll try to look at my grid lines. Does it kind of look like it's at like 10.5? Does that point look like it's at 10.5? Or I guess I could use that point, which is at 35.15 maybe. Okay? I'm trying to find one that's like very right on the line. Okay? I'll go ahead and use this one. This first point, 10.5. What that's saying is it was $5 million to make 10,000 chips. All right? That's a lot of zeros, okay? So when I start, yeah, 2, 3, 4, so it's like $500 a chip. This one doesn't say anywhere 500, but when I look at this, like if I really look at this, do you guys see that it's like a slightly below? So I feel like it's 480, I'm gonna go with that. Okay, but that's why you wanna get it as close to the grid line as possible. All right. Okay. The profit, blah, 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 the total revenue must exceed the cost of production. The cost total is 8250. What's the max number? Blah, blah, blah. Guys, you know what this is called right here? That point? That's the break-even point. If I sell less than 80,000, I lose money. If I sell more than 80,000, I'll start making money. And so it says, what is the, and I don't know, I kind of hate this question because it's so dumb, because it's like 79,999, 8,001. But basically, what's the maximum number we could sell without making a profit? I mean, I think it's just like 80,000. Because as soon as we sell the next one, now we start making a profit off it. Okay? It's not exactly my favorite set of questions right there, but that's fine. All right? So, we're going to do, I'm going to give you guys 4 minutes to do this first one, this checkpoint review. I'm going to say, I like to tell you whether they're like easy or hard, because it would be, easy would be in the first 20 questions, medium would be between 20 and 40, hard would be between 40 and 60. So I feel like that's easy, that's medium, that's easy, honestly, if you remember what I taught yourself. Okay, so you should be able to do that in 4 minutes. Let's see how many of these you guys get. Yeah, because you want to spend like 30 seconds on the easy ones. Okay? All except for one, yeah. Okay, ready, set, go. All right, guys, let's do like 30 more seconds.
This is with the calculator.
Yeah. Everything on the ACT is with a calculator.
Really?
Everything.
Carol is. I'm just kidding.
Everything on the ACT is what?
Calculator. You can use a calculator in everything. Yeah, the biggest difference between ACT Math and SAT Math, so when I teach those classes, the biggest difference is there's two. SAT has a calculator and a no calculator section. ACT is all calculator, and the other difference is SAT has those grid-in questions where you have to answer, it's like free response kind of, where you have to grid in like 1/3. ACT is 100% multiple choice. Yeah, there's no grid in, so. The math level's a little higher on the ACT, but yeah, there's no, yeah. Anyway, that's the biggest difference. Okay, you guys, let's take a look. For number 1, I got 3. Did you guys get 3 in? Okay. Right. 48.
It's total?
Yeah. 48, and we're increasing it to 72. And then it says, if the recipe was increased, how many total cups of white and brown sugar? White and brown, so it's 2 and S. We get this total cups of white and brown sugar together, and the original recipe has 2, so I gotta find the total. But they just mess you up on one little thing, right? The ratio is 1.5, but you have to multiply to find the total cups, okay? Okay. Yeah. Yeah. Right. Well, no, because then, because you have to include the 72. Like, where did you do the 72 in that? Not you. All right, you guys, least common denominator. You might have been able to just look and tell. Here's how I would do this. To me, this is the fastest way. Start with the smallest number and just see what it divides by. Does 96 divide by 80? No. Then I did 40. 480. Does 480 divide by 80? Yes. I typed this in my calculator. Does 480 divide by 15? Yes. Does 480 divide by 32? Yes. So I just stopped there. Okay? All right. 3 was the only one I thought was a little on the tricky side. Check it out. Ty is reading the Iliad. He puts off his assignment until he has only 2 weeks left. That is such a vibe, Ty. Don't we all, though? So, he read 1/24 of the book, and then he read nothing for 4 days.
This is literally me.
Right? Yeah. Okay? And then he's like...
I noticed the didn't read until 2 weeks before, and I was like, hey, that's...
And then he has 7 days to finish it. Sometimes I'll draw myself a little chart like this. Guys, 100% this is a calculator question. Were you guys like getting common denominators and stuff? Come on now. All right.
Yeah, same. I just can't.
324 switches into 8.
Yeah, that's what I did too.
You have an 8, then you have 7 more 8s.
Okay.
Yeah.
I mean, yes. Okay. And that's fine. But look, I did this on my calculator. Watch. I did 1 minus 1 over 24 minus 1 over 24 minus 1 over 24. Because I'm trying to use my brain power for later. So I typed in this.
But that didn't take any brain power.
I
I got 2 other questions wrong.
Yes, thank you. Okay. And then, guys, okay, and I pushed equals, and then I divided that by 7, and I pushed equals, right? Divided by 7. Now, remember last week we talked about the best calculator is the one that you know. So you're going to practice on the same calculator every single time. How do I turn this answer into a fraction on these calculators? You guys know? Math 1. Math 1. If I could tell you one thing that will really help is turning decimals to fractions. So make sure you know how your calculator does that because you can go kind of fast. Okay, so on this I did 1 minus 1/24 minus 1/24 minus 1/24 equals, I got a decimal. Divided by 7 equals, I got a decimal. Math 1. and it turned it into a fraction for me. Okay? Good? All right. Did everybody get number 4 right? Because if you didn't, I'm kicking you out right now. Yes? Delano?
It's a real good thing I
I
got.
remember the exponent rule. I forgot that 2 times 5 is 10.
Multiply, add. Okay? All right. How do I solve for x on here? I multiply both sides by square root of 5. And what's square root of 5 to square root of 5? 5. Square root of 25 over 5. Okay. In case you suck at percents, do you guys remember the formula I taught you last week? Okay, look. Is over of percent over 100. I use this just to make sure that I'm doing it right. 33 is of 132. Okay, x 100. And then remember I taught you also the fast way to do proportions, which is multiply, divide. So on my calculator I just did 33 times 100 divided by 132. Okay, and I got 20. You can just do it on your calculator right now.
I don't remember how to do percentages. Hold up, say that.
Okay, you're good, you're good. Okay, so this formula that I like to use, we talked about this last week, which if you weren't here last week, by the way, I have the video that I'm going to post. Is over of equals percent over 100. This is a very cool formula that will help you on all these type of percent problems. So when I read through this problem, I go like this. 33 is, so I put that on the top. Of 132, so I put that on the bottom. What percent, so I put x there, and it's always 100. And then what I do is I just cross multiply, okay? So the fast way is you multiply the numbers across from each other, and then you divide that. All right? So we multiply 33 and 100, because what I'm really doing, and I wouldn't write these steps down if I were you, like on the actual test, I'm doing 132 times x equals 33 times 100, and then I'm dividing that over. But I just do it all on my calculator. Okay? Okay. Number, quantity, and foundations. We're going to read through this. And you guys are going to be like, for real, Mitchell, I know this stuff. And I know you do, but you got to know what these words mean. Okay? Oh, bye, Chris. Are you leaving, Chris?
Yeah.
Okay, bye, Chris. Oh, do you have to go to your day date? Well, enjoy your day date. That's so cute. Because it's not a real thing. It's only a thing in Utah. Okay, it's fine. I'm fine. I've literally never heard of a day date.
We don't do that anywhere else.
I think we can take it away.
No, it's adorable. Chris, enjoy your day date. All right. It just triggers me because I never got to go on a day date. All right, you guys. An integer. Positive, negative, or 0 are integers, you guys. Okay, when I ask you about digits, 0 to 9 is what it means when I ask you about digits. An odd is a number that's not divisible by 2, and even is a number divisible by 2. I think you guys know this. I don't have these memorized. I guess I could think about it, but it talks about adding and subtracting even and odds and multiplying even and odds. I wouldn't probably worry too much about that. Okay, this stuff is important. So here we go. Consecutive integers always go up by 1. Okay? So a lot of times in problems that ask you to make a list of consecutive integers and you don't know like where it starts. So I usually will start with x. What's the next number after x? The next consecutive number? X plus 1. What's the next number after that? X plus 2, x plus 3. Does that make sense? Okay. Now, consecutive odd or consecutive even. So let's look at this even one first. If it starts with x, what's the next number? X plus 2. And what's the next number? X plus 4, x plus 6. Because they're going by 2's this time. Skipping every other one. Now, a lot of people might think, okay, now we're on the odd numbers, so it's going to be x plus 1, x plus 3, x plus 5, because it's odd numbers, right? It doesn't work that way. It's still increasing by 2. it's still x plus 2, x plus 4, x plus 6. So the only difference is, did you start with an even or did you start with an odd? But they're still two numbers apart every time. Okay? So see if you could fill this in. If x is an integer, what are the next two consecutive after x? So the next one would be x plus 1, x plus 2, because it's just regular consecutive. If x is even, what are the next two even ones after that? Plus 2, plus 4. If x is odd, what are the next two odd integers after that? Right, it still skips by 2 and 4, right? Makes sense? Okay. This is just kind of funny. The only reason I even really put this in there, okay, is, like you guys know what a positive number is, or a positive number is a negative number, okay? You know that. But every once in a while in a problem, you'll see the word non-negative. Like x is a non-negative. Why are they being obnoxious saying non-negative instead of just saying positive? Like, because it can be 0, that's correct. The only time you'd ever see them use non-negative, that means all the positives plus 0, and if it says non-positive, it's all the negatives plus 0. Does that make sense? So you just might see that every once in a while, so that's just a very tiny thing. You see that more in like our calculus class and stuff like that, or upper level math classes than on the ACT, but there you go. Negative, I'm not going over negative, how to add and subtract negatives. I think you guys are fine. All right, so, I know, I'm still not going over it. Absolute value means, when you guys first learned it, your teacher might have just said, oh, absolute value bars, boom, make everything positive. Like, that's true. But what it really means is, it means the distance something is from 0. So the absolute value of 2, well, that's 2 away from 0. And the absolute value of negative 2, that's also 2 away from 0. The typing got messed up here when I did a little copy paste. This is supposed to say if x is bigger than 0, if x is less than 0. Okay, if x is bigger than 0, what's the absolute value of x? It's just x, because it's like a positive number doesn't change, right? If x is less than 0, what's the absolute value of x? It's negative x, because it changes. Like if it's, okay, if x is less than 0, like let's say it's the number negative 3, the absolute value is 3. What's another way to make a negative 3 turn into a 3? Just multiply it by another negative. So that's kind of what that's saying. Okay? So, okay, so you know how in order of operations, for years you guys probably learned it as PEMDAS? I saw some like books now that are trying to teach it as GEMDAS. They don't like PEMDAS. Because PEM stands for parentheses. But like then where does absolute value go? They call it now grouping symbols. Because a parenthesis, a bracket, and absolute value, those are all grouping symbols. They're just all parentheses, right? Yeah. So it basically says, simplify just as you would with parentheses. But, you know, GEMDAS if you want to be fancy. So multiply first, take the absolute value at the end. So that's negative 1, so that's 1. Okay? That's 2. That's negative 3, so the absolute value of that was actually going to be 3. And then I subtracted, I get negative 1. So just be careful of order of operations. Okay, I want to give you guys time to do these. I think you can do all of them. I'm going to call that easy, medium, and I think 3 and 6 are a little more on the hard side. Okay, and this, because I know it didn't come out very well, on number 2, that's a plus, not a minus.
On number 1, is that supposed to be?
And number 1 says negative 3, absolute value of negative 6 plus 7, absolute value equals question mark.
No, that one just looks like a divide sign on number 1, and I was
Wait,
like,
what is that? Oh, that's a plus.
Yeah, sorry, it's like the crappy.
I was like, this is not.
Since when did they use divide signs? What does that mean?
Right. So 1 and 2 both have pluses. Anyways, let's take 5 minutes. No, 4 minutes. Work fast. Let's take 4 minutes.
Is that minus? Plus. Oh my gosh. That makes way more sense.
That's true, but Isaac didn't even try. Oh, I forgot Ben was the
Oh, that's time, everybody. Okay. Here's what I got. Number 1, I got B. Are we all good on that?
Yes.
We don't need to go over that, right?
Couldn't do number
All right. Number 2, you guys, rather than trying to set up an algebraic equation, sometimes it's actually faster to plug in. Okay? So I can algebraically teach you how to solve that, but honestly, you can go faster by plugging in. If I plug in -4, I get 4 and -2, so it's not that. If I plug in -2, I get 2 and 0, so it's not that. If I plug in -1, I get 1 and 1, so it is that. So I did not do this algebraically because a lot of times, even for me, like I know how to do it algebraically, plugging in is faster, okay? So always try to go to that. If you think that would be the fastest way to do it, go to that. Okay. Man, I thought 3 was, you really had to think on this
3
one.
is cool.
Yeah, I couldn't do that
This
one.
one's a plus sign.
I
guessed and I
got
got it
D.
right.
Okay. So this is one called choosing numbers. All right. This is one way you can do it, is you can choose numbers, and you can plug into these different things too. But here's what I did. I was like, oh, I should find a pattern. Okay. If J and K, how do I make sure that it's an odd? And I was like, well, what do I do 2 times 3? Okay, that's even. What if I, so that's an even and odd. What if I do an even and an even, like 4 times 6, that's an even. So the only way I can get that is an odd and an odd, and I was like not seeing the patterns, right? But the one thing I know about even and odd numbers is this. 2 times anything is even, right? That's kind of the only thing I know about odd numbers is 2 times anything is even. So how do I make that odd? Add 1 to it, that's right, okay? So in fact, a lot of times in proofs, when you're doing a proof or, I won't talk about calculus too much, even though half my class is in here. When we start doing this calculus stuff, you guys, where we're trying to make it go to an odd exponent, we'll usually use 2n plus 1. Whereas when we use an even exponent, we use 2n.
And we can just use that because it guarantees it'll be.
Yeah, because the only way to guarantee an even is to multiply by 2, and then if I add 1, it multiplies by odd. Or sometimes I'll use 2n minus 1 for an odd, and that's the same thing. So when we start doing sequences and series, you guys will see that. Okay. Anyways, that was a cool one. I like that one. I also plugged in this. Now, I started by plugging in, and I got to see a little bit of a pattern, okay? And again, there's different ways you can do this, but I started with, okay, if a is -3, I'm solving that. I can solve that. If a is 0, I'm solving that. And then I started thinking, well, what is it that I can't solve? I can't solve when the absolute value equals a negative, right? Because the absolute values have to be positive. So I skipped down to that, and I was like, oh, if a is 8, I'd have to solve -1, and that's impossible. So that's how I did that one, okay? So it still is kind of a plugging in, but I saw a pattern. All right, if the greatest of 3 consecutive integers is x, what's the sum? If the greatest was x, what's the one right before it? What's the one right before that? I love it. Sum those all up. 3x is 3. Now let's say I hadn't just taught you that thing about the x plus 1, x minus 1, or you forgot or whatever. Did anybody do this in a different way? Okay. And did you get it right? How'd you do it? Okay, great. And so what did you just literally circled? Okay. So someone last period was thinking this. They're like, again, this is another strategy. I might not use it on this, but I would use it in a lot of places. It's called choose numbers. What's that? Yeah, so you did do choose numbers. Okay, so Raina, what did you choose? Okay, that's exactly what the person last period did. So last period, I had someone that was like, I just chose 4, 5, and 6 as my numbers, which meant that x was 6. And then what's the sum of those numbers? 15. Okay, watch. Does that give me 15? No. Does that give me 15? No. Does that give me 15? No. Does that give me 15? Yes. So that's another way to do it. But that's a really good strategy on other like difficult type questions. Is just to pick numbers and see how it works. Okay. So I do that a lot. I am definitely going to use my strategy of choose numbers over here. Did anybody get this one right?
I did.
Okay. Average is basically like, well, the average of 2 numbers is finding the one right in between, right? So let's say I pick numbers for m and n. And this one tells me n has to be positive and n has to be negative. So what if that's like positive 5 and negative 5? What's the average? 0. What if that's positive 100 and that's negative 2? The average is a very, very, very big positive number. What if that's negative 100 and positive 2? The average is a very big negative number. So we just can't tell. Because we don't know anything about m and n. If it had told me that, you know, the absolute value of n is more than the absolute value of n or something, but it didn't tell me that, so I have no idea. I can't tell. Okay? Good on that stuff?
Yeah.
All right. I'm considering skipping Algebra Foundations just for time's sake. Do we need Algebra Foundations? Okay, we'll do it. All right. That's fair. Okay. A couple of quick things you're going to want to remember. Anytime you're subtracting, you distribute the negative to the other side. And then it's just all about combining like terms. Right? So you guys remember combining like terms? So 3k plus 5k minus 4 minus 4 minus 4. So that's what, negative 4k. And then 5 minus 5 is 0. Okay? Like you guys know how to do this one, right? So if I put each part over 2x, I get 3x minus 1 plus 4. That's how I do dividing. Substituting in, you can completely do this on your calculator. Let me just make one little statement on that. When you guys are plugging a negative number into your calculator, please use parentheses. If you don't, it can really screw you up. Yes, did I do something wrong?
Yeah.
Why is it
8
plus
over
4?
2x is
Because it's plus 4 over x. Jeez, guys, just listen. Sorry. Plus 4 over x. Because I'm going fast because I want to get to fun stuff. All right. Just plug that into your calculator, but all I'm saying is just like use parentheses. Because if you type in your calculator, if you type negative 4 to the third, it will give you the same thing. But if you type negative 4 squared, it won't be right. You have to type parentheses. Okay? So just when you're plugging things in, just type parentheses. So if I go like parenthesis negative 4 to the third plus 3 parenthesis negative 4 squared plus 10. And I got negative 6. Okay? You know, when I was doing that, I was like, yeah, split up the fraction, take an integral. Like, yeah, we okay.
That's what I was thinking too.
Yeah, we've been doing so much. All right, distribute. Distribute. Okay. Those, can I not do those? You guys are fine. Solve that. Can I not do that? Are we fine? Okay. The only thing I need you to remember about inequalities is when you multiply or divide, so like underline or highlight this, by a negative number, what do you have to do? Flip the sign. So I just need you to remember that about inequalities, okay? All right. Okay, so let's take a look. So here's how I solve this. Basically, you pretend it's an equal sign, okay? I add 4, so negative 3x is less than negative 15, and then I divide by negative 3. And that's where you would switch the sign, and negative divided by negative is positive. On a number line, if you're shading on a number line, you guys, less than or equal to, greater than or equal to is a closed circle. Less than, greater than is an open circle. Remember that? And so x is greater than 5 would be like open circle, bigger than. Okay? All right, let's see. These are algebra, they're like all easy. No, that's easy, that's easy. That's medium. I would call that medium, I think, although I think it's easy. That's probably medium. That's probably medium. There you go. Okay, let's do 4 minutes on this. I think you guys can get all 6 of those. 4 minutes. boy, that's fine. Okay. So this is gonna be, number 1, I got A. Did you guys do that? So that's stupid. Number 2, I got 6x minus 12, but then I had to look at this and all of them factored a 3 out, which is dumb because a 6 could factor out, but whatever. 2x minus 4. So I got J for the second one, yeah? Guys, no, it's J. Distribute the negative plus 4x minus 9. You guys get that wrong.
No.
I need to review that.
On number 2, I got it, but it annoyed me.
For some reason.
Oh, it annoys me too.
Positive was a positive.
Half the stuff annoys me though. Okay,
They just fully simplified.
now, I would most likely I would do this one of 2 ways. I would either plug in numbers. Yeah, Jacob.
So I just plug number 3 into my calculator, is that allowed?
Absolutely. Oh yeah, like did you put this, well you have the computer solver, but if you put this as like with x's in one and x instead of equal to each other, 100% allowed, it's perfect. I love it. Okay, so yeah, you can do that if you know how to do it on the graphs, you can definitely do that. Alright, you could plug in numbers. The fastest way I'm thinking now, I was going to say let's just plug in numbers, but look, I'm going to show you guys something. If I bring this 2 over, what do you guys notice? If I add the 2 to the other side, what do you
That would
notice?
be helpful.
Do you notice that? So what does A have to be? Yeah, that has to make 1, so A would have to be 9.
That's a
That was a little faster.
much quicker way than I did.
When I see little fast tricks, I will tell them to you, okay? A lot of times the tricks are what, like, okay, the people that are trying to get like a good amount of time at the end of the test, if you can get like a good amount of time for those last 10 questions, they'll take a little bit more time. So the point is to go kind of fast through the easy and medium stuff. If I see some that have little tricks like that, I'll show it to you. Anything I can like see, okay? Did you guys understand that?
Yeah,
Sure.
but that doesn't, if there were a negative 2 in the, as one of the multiple choices, you wouldn't get it.
Right, that's true. But they will never do that to you. They wouldn't give you 2 answers that would like work. Because negative 2 is another solution
So
also.
like, if negative 2 were there and 9 wasn't there, then that strategy.
Then it would be, oh yeah, that's true. Yeah, that strategy wouldn't work, then I'd have to say, oh, how could those be equal? So basically you could set the top equal or the bottom equal, I guess. Yeah, and I don't think they would make it that difficult, I don't know. Okay. Guys, for number 4, I mean, you can get a common denominator, you can make this a regular equation. I'm fully going to do this on my calculator, right? To solve for x, first I'm going to add 1/9. Can you guys do that on your calculator?
So dumb.
Do negative 4/3 plus 1/9.
Oh my goodness.
So much.
And then I'm going to just multiply by 6. Whatever I get, I'm going to times 6.
I'm so stupid. I did this all weird complicated.
I know, I was like,
before I got the
Yeah,
calculator.
got it.
Hey, just like 4/3 is bigger than like 1, and so it has to be bigger than 6.
Yeah.
I mean,
I don't know. Yeah.
Yeah.
I got that, so I just know it's here.
Wait.
but that would give you 2 possible
Oh,
answers
negative,
of
right?
F and
Yeah, and also because it's negative. Yeah. So I just said, well, I'm going to add the 1/9 over. I'm going to multiply by 6. I solved it, and I said, okay, it's between -7 and -9. That's the fastest way I can think of doing it. You could say 6, 3, and 9 all go into 18. And you could multiply both sides by 18 and go, okay, 3x minus 2 equals -24, and like solve it, but that takes too long. I'm going to use my calculator, okay?
strategy to remember that you have a calculator.
That is the strategy, is to remember that you have a calculator. It's a very good
Exactly.
strategy, honestly, because you forget. Okay, this is easy, right? Add 1, divide by 2, x is greater than or equal to 3, look for the one that's at 3 colored in. That's not hard. I probably should have said that was easy, but whatever.
I have really good luck with it.
Okay, how did you guys do number 6?
Logic.
Process of elimination logic, that's good.
I just drew it.
Did anybody like,
Crossed off anything that had a.
oh, that's good. So like Q is bigger than T, so I put Q and T.
No, I was thinking.
P is less than T, so that has to be there.
That's what I did.
P is bigger than S, which is there, but S is, wait, where the hell is R?
R is, it's the line down, second line.
S is greater than R, but S could be around here somewhere. Wait, what, why am I,
Miss Mitchell,
that's not the way I did it. Yeah.
I just did T is less than Q, so it can't be Q. P is less than T, so it can't be.
Oh, that's good.
That's what I.
Oh, okay,
that's
that's
what I
probably
said.
smart.
You just crossed them
T
off.
is less than Q, so it can't be Q. P is smaller than T, so it can't be T. S is smaller than P, so it can't be P. R is smaller than S, so it can't be S. That's good. I like that. I think I made numbers, I went like, okay, if that's 2, I'll make that 3. So that's 2, that would have to be 1. So that's 1, that would have to be 0. I think I did that, but same idea. Cool, I love it. Okay,
I basically.
so I was giving a mock test one time. Mock tests are something we do. If any of you guys are interested, I will do this for you out of the kindness of my heart. Mock tests are things that we do under testing conditions, and I would give you an ACT one, and I would give you an SAT one. I would grade it, and I would tell you which test you're better at, right? So if your college or whatever accepts both, a lot of times I'll do this mock test thing, and I'll tell you which one you have a better chance at. Okay, so I was giving a mock test to these students one time. Okay, guys, it was the ACT, and they got done with the math portion. I was like, hey, how was it? They're like, man, that sucked. Like, everything was geometry. It was all geometry. I was like, that's weird. So I went back and counted the questions. A fourth of them were geometry, not everything. But they felt like it was everything because they hadn't done geometry in so long. You know what I mean? So they haven't done it. They're just like, oh my gosh, so much geometry. So there's not a ton, but they felt like there was a ton. I don't think we have to go over too much. Plotting points. Are you guys fine with plotting points? Okay. They're putting slope-intercept form in geometry. That's fine. Y equals mx plus b. That's all right. Basically, to find the slope and y-intercept, I just solve for y. I'll show you one example here. If I minus the 12x and the 5 over, standard form is done. Negative 3y is negative 12x minus 3. If I divide by negative, y is 4x plus 1. And then we have our slope and our y-intercept. Okay? So anyway, with lines and stuff there, guys, put that in geometry. I'll show you one more thing on here. It doesn't ask, but if you're finding y-intercept and x-intercept, I'm going to find both. There's something called the cover-up method. Because the x-intercept is when y is 0. So if I'm finding the x-intercept, it's when y is 0. So what would the x-intercept be? 6 over 14, and then you could like reduce it or whatever. The y-intercept is when x is 0. So that would be 6 over 8. So that's something called the cover-up method. It's really fast if you're trying to graph or something like that. Okay.
Yeah, I think it will.
Slope, you guys. You know there's between positive slope, negative slope. This is an important equation. I think you all know this. The biggest thing I'm going to tell you to be careful on with slope is on the graphs that they give you, they intentionally try to trick you by labeling the axis weird. So I was doing this question one time where I was like, look, it goes up 1 over 2. But the scale was actually up 1 over 4 or something. So you got to be very careful about how it's labeled if you're counting it, okay? Okay, very important. Parallel lines have slopes that are the same. So for example, 2 and 2. Those are going to be parallel, all right? Perpendicular lines have slopes that are called negative reciprocals. If you don't remember that word, that's okay. It basically says if it's A over B, it goes to B over A, and if it's positive, it goes to negative. So you have to do two things for a perpendicular line. You have to flip it, and you got to change the sign, all right? So, yeah, so as an example, 2 and negative 1/2. All right? I think I've told you guys this before. If you've had my class, we've talked about this before. The way I remember vertical and horizontal lines is I remember Vox and Hoy.
Oh,
We
yeah.
talked about that. A vertical line has an undefined slope and they're always x equals. It's just like if it's x equals 2, it's a straight up and down line. Okay, that's what the equations are. And then Hoy, a horizontal line, have a slope of 0 and those are always y equals lines. Okay? I guess we could do this. Okay. Let's find the slope of P and R. I'm just going to count this. This goes down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. Down 4 over 6, which is like 2/3. The slope of QS is undefined. What is anything parallel? 4, negative 4, down 4 over 6, right? Okay, what's anything parallel to PR will also be 2/3. Anything perpendicular will be positive 3/2. Okay, that's how that works. Negative reciprocals. And parallel to QS would be undefined, but what would be perpendicular to that?
0.
0. So 0 and undefined are perpendicular to each other. That's right. I just don't know if we want to take time to do this. I think those are too easy. We're going to skip past those. You'll be fine. We're going to do geometry, okay? Geometry stuff. Here we go. All right. Right angles. How many degrees?
90.
90. How many all the way around a circle?
360.
360. Very good. Okay. A vertical angle, whenever you guys see an X, you're going to have vertical angles. Okay? An X. A vertical angle tells me the one across from each other is equal. So like A and C are equal. And then B and D are equal. What do triangles add up to? 180. What do quadrilaterals add up to? 360. Now guys, they give you a formula up here for memorizing the angles that adds up to of any polygon. And it's like n minus 2 times 180. I'm not trying to remember formulas, okay? It doesn't work for me. You can understand what this formula means. But basically, here's how it goes. Think about this. If it has 3 sides, it has 180 because that's a triangle, right? If it has 4 sides, it has 360. It adds another 180. So if it has 5 sides, how much does it have? It adds another 180, 3, 4, 540. 540. Every time you add a new side, it adds another 180, okay? 6 sides would be 720. 7 sides would be 900. So every time you add a side, you add a new 180. Do you guys want to know why? It's really fascinating. Do you care or no? Check this out. If this was a triangle, so that has 3 sides. When I add 4 sides, what is it adding? Another triangle. So it's another 180. It's adding another full triangle. Let's say this was a 4-sided figure. 1, 2, 3, 4. That's 360. I add a side. So I'm taking away that and I'm adding that. What am I adding? Another triangle. Every time you do it, you're adding a new triangle. So we just add 180. Every time I take 1 side and I add 2 sides, I'm adding a triangle. Kind of an easy way to remember it, right? Kind of cool. And if it's something called a regular polygon, meaning all the sides are the same, all the angles are the same, I would just do 540 divided by 5, and I would get 108 for each angle. Okay? Yeah, really, really easy stuff. Did you guys do so much with this or no? Okay, so this is called 2 parallel lines cut by transversal. If you had a geometry class, which we're all integrated in Utah, so I don't really know where that is. Probably Sec 2, maybe? Like we do Math 1, Math 1, Math 2, Math 3. So I don't know what you guys do geometry, but We got vertical angles, alternate interior, corresponding, alternate exterior. You do not need to memorize this. If you know two things, you can do all these questions, okay? These are the two things you need to know. You need to be able to find Z angles. Okay, can I show you guys what a Z angle is? It makes a Z. And on the inside, Z angles are always equal. So when you get to these sometimes a lot of these really complicated drawings, and I'm like, what the heck is going on? I find my parallel lines, and if I can make a Z, I can find equal angles, okay? Those are known as alternate interior, but I just look for the Z. That's one thing I try to find, okay? The other kind of angle in geometry that I like to look for with this are called the C angles. Now why am I making my C like that? Because look, that's a C angle right there. Now guys, are those equal? Those are not equal, okay? Those are what's called supplementary. Supplementary, okay? Anybody know what the word supplementary means?
They add to 180.
Add to 180, very good. And like any line, the angles will add to 180, right? If you guys can find the Z angles and the C angles, that's really all you need to know, okay? Just remember, Z's are equal, C's are 180. So check it out. If a problem contains parallel lines, identify and label all equal angles. Heck no, I'm not doing that. Z angle. That's so simple, right? And then it's like, let's look at my vertical angles. Well, guys, if that's 100, that's 100. If that's 100, that's 100. Right?
Oh my goodness.
This is a straight line right here. So if that's 100, what's this? 80, and then by vertical angles, that's 80, and then that's 80, and then that's 80. You know what I mean? And if I look at the C angle, 180 are supplementary, you know? So you're going to use this strategy when you have parallelograms. I'd probably use a C angle. When I have a trapezoid, I would use a C angle.
Wait, will you scroll back up?
Oh yeah, for sure. Sometimes you have like a diagonal of something. Like every once in a while it'll give you a trapezoid and it'll put a diagonal in your trapezoid like that, and it'll ask you questions about it. So if there's a diagonal in my trapezoid, then guess what? I'm going to go back to using a Z angle. Okay? So just always look for the Z's or the C's, and I think that'll really help you. Alright? So let's do these together. Okay? Just for time's sake, let's just do them together. Some of them I'll probably just set it up and we won't even finish it because I think it's pretty straightforward. How would we find X on this, you guys? Add them together and equals 180. Because straight lines are 180, okay? All right, for number 2, I'm not going to solve it, let's just leave that like that. What's the value of A plus B? Oh my gosh, you guys, there are Z's all over the place. Look, boom, 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 Z. That's 40. Boom, boom, boom. That means that's 40. That means this one in the middle that makes a straight line is 140. That's 140. Okay, I see more Z's. Hang on.
I don't know where Lydia is, but I can hear her giggling from all the way over here.
She's enjoying herself so much as well. If that's 40, that's 40. There's another Z,
They sound like little.
which means that's 40, means that's 140. You guys see how this works? And if that's 40, that's 40, that's 40, that's 140. So if I'm adding A and B, it's 140 and 140. I'm just going to get 280. So just looking at Z's and C's all over the place, basically. Okay, I can think of 2 different ways to do this problem. You guys, I could do a Z. You guys see the Z right there? You could do that. Or I could do a C. Okay? Now, either way, we're looking for L. It says, what's the measure of LMN? So see if you guys can find that for me real quick. Remember, we got until 12:15, so I'll try to finish this up. If you need, yeah, if you need to go, you can go. We'll go a little bit more so I can get through some of this geometry stuff. So guys, the key is going to be to find this little angle right here, because then I can have them together, right? Okay, what's that little angle right there? Yeah, the total is 107, because look, if I use the Z right here, I could go, well, that's 80, and then, oh, look, I have a triangle. And I can subtract it from 180 and say that that's 27. Delano, go for a walk real quick, and then come back. Because I gotta go fast. So that was like 107. I could have also done that with a C, okay? All right, you guys, look. Hexagons have 6 sides, so what's the total number of angles for 6 sides?
720.
Was this? Yeah, it was 720. Start with a triangle and add 180 a bunch of times, so it's 720. If I divide that by 6, how much is each angle? 120. So each of these angles are 120. Now, what kind of triangle is that? I guess. That's called? No, it's obtuse. That's called?
Oh, that is right.
That's very obtuse. Anyways,
And then you said cute, and I was like, oh,
it's a isosceles triangle, okay?
I was gonna say isometric. I remember the
Isosceles.
ice. I remember the ice.
That is not.
So 180 minus 120 is 60, and if I cut it in half, it's 30 and 30. Okay? Okay, so I found out the top was 120, but this is called an isosceles triangle. These are equal. So I did 180 minus 20, and then I split it in half. Okay. All right. This is, I would consider this a hard question. Check this out. ABE is smaller than DEG. Now, I think I'm going to choose numbers for this. If ABE is smaller than that, maybe I'll make that one 30, and maybe I'll make that one 50. Okay? Does that work? Because I just do better if I add numbers to stuff, all right? Okay, now check it out. Which of these cannot be true? Could B and BF and DF, could those be perpendicular? Sure, it has nothing to do with those over there. Sure, that could be true, so it's not that. Could ABC, that's here, and DEG, that's here, could those equal 180?
Yeah.
Well, I don't know, let's see. If that's 30, what's that?
That has to be
180 minus 30? 150? Yeah, and if this is 150 and this is 50, does that equal 180?
No.
Definitely not. So I'm not even going to look at the rest of them. Okay? That's Cassidy's hat I borrowed. Okay,
Who's that?
triangles, let's see real quick. Alright, Delano, for heaven's sakes, I only got 10 more minutes.
I thought we were done.
No, bro, but you can take your stuff if you're good. Good job. But I got 10 more minutes. So I want to finish. Okay, here we go. Ready? Isosceles triangle. 2 sides are equal. Base angles are equal. You don't have to read through the rest of those. That's pretty good. Okay?
Hey, that equilateral triangle, that's the cube triangle.
Yeah, buddy. It is. You're right.
I know that.
Equilateral triangles are always 60, 60, 60. And the sides are equal. This statement right here is actually pretty important. I believe that's something known as the, well, okay, there's 2 parts to the triangle inequality theorem. This one says, if I'm opposite the biggest angle, it's the biggest side. If I'm opposite the smallest angle, it's the small side. That makes sense, right? Based on the opening of the mouth of the angle. And then the last one, this is called the triangle inequality theorem. This is kind of important. It basically says I cannot make a triangle. That's not a real triangle. That triangle does not exist. Wait, no, hold on.
That was an choice. Do you want 12?
That's not a real triangle. That doesn't exist. The other one does. Okay? That triangle doesn't exist. Because the straightest distance between 2 points should be a straight line. But what this triangle is trying to show me is that, oh, if I take the long way around, I only have to go 10 miles instead of 14. That makes no sense. So triangle inequality theorem, that's not a real triangle. A squared plus B squared equals C squared. You guys okay with that?
Yeah.
Okay.
I remember.
My friends, especially those of you in my calculus class and my honors class, could not remember your dang triples.
Yeah.
I can do the Pythagorean theorem.
I know, but I would like you to remember your triples. These triples are what they will use when they're trying to make you go fast. It's not memorized. It's 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17.
I can still memorize that. 3, 4, 5. And then the rules of trig 5.
Triple.
Heck no. All right.
Okay.
I remember that.
If you're not going to memorize them, will you please memorize this one?
What I know.
Yes, I know 3, 4, 5.
Okay. And maybe this one.
5, 12, 13.
5, 12, 13.
Those are the two most common. Alright.
Wait, what do you mean by triples?
Okay, a triple is when you do the Pythagorean theorem, it's where all three numbers are integers. So for example, like look at this question right here, okay?
So there's no
3 squared plus 8 squared is c squared. 9 plus 64 is c squared. So 73 is c squared, so c is the square root of 73. Triples are special because they're all whole numbers. And they're ones they use in problems a lot. So if I did that with 3 and 4, 3, 4, 5, 5, 12, 13, these are triples. Okay? It's the most common ones. So like,
none of the siblings.
look, what's 3 squared plus 4 squared? Well, that's 9 plus 16, that's 25. That's 5 squared. There's a triple. Okay? Okay, let's not do questions. Area volume, can you guys help me fill these in real quick? Yes. These are the ones that you have to know. Oh, it's not that hard. Calm down.
If they are.
Triangles. 1/2 base times height. Okay, what's the area of a parallelogram? Same as a rectangle. Because if I take this triangle right here, right, and I move it over right here, did I just make myself a lovely rectangle? Okay, or whatever, I just did. But that's the idea. It's the same as a base times height, it's the same as a rectangle. Guess what? The area of a rhombus is also base times height. The diagonals are perpendicular bisectors. That's kind of important. A rectangle has all right angles. The perimeter of its WL is 2 widths plus 2 lengths.
Wait, what was kind of important? Sorry.
Oh, in a rhombus,
Okay.
the diagonals are perpendicular bisectors.
What is a bisector?
Means it cuts it perfectly in half.
Okay.
So it means that and that are equal.
Wait, that's
That and that are equal, and it makes right angles.
okay.
Kind of a cool property of a rhombus. Okay, Weston, go wait outside, or be quiet for a minute.
I'm still gonna make you memorize. I'm not gonna remember it.
You guys are good. The perimeter is 4s. If I add all the way around, the area is s squared. Because on square, it's just calling it side. They just changed the letter. All right.
And 17.
Okay, and I'm going to show you a couple more things. Here we go.
I'm 17.
Okay, guys, the area of a circle, pi r squared. Okay? Circumference,
Is the
2 pi
derivative
r.
of
It's the derivative. It's so cool.
that? Yeah, it is. No, it's
Diameter is just two radiuses. I don't care if you know what pi is. You just use the pi button on your
Wait,
calculator.
the replace first there too.
The circumference is the derivative of
Isn't that crazy? Okay, but
wait, no, wait, math.
let's go back to ACT stuff. Okay, there's something called area of a sector. Okay, area of a sector. Do you guys see that that's a part of the circle, of the whole area? Okay, and the part is theta over 360 of the whole area. What's the area of a circle? It is not a new formula you need to learn, but this shows up on the ACT. It's a fraction of the whole area. It's how many degrees out of 360 of the whole area. So that's called area of a sector. And then I'm going to do arc length. And that's the same thing. It's a proportion of it. It's theta over 360.
Oh, I remember.
But instead of pi r squared, it's 2 pi r. So you're not memorizing new formulas. If you know area and circumference, it's just a fraction of those. All right?
Mitchell.
Yep.
How did you remember the first two triangles real quick? Look, go ahead.
Okay, go.
Go ahead.
3, 4,
No.
3, 4, 5.
5, 12,
Yeah,
13.
5, 12, 13.
7, 24,
15,
25.
25. You guys got it.
You can't just make me say it. Yes? No, you can't.
Okay, guys, we'll call it good for there. If you want to do that homework I gave you and the practice test, it's up to you. You guys can do those, okay? And we can go over stuff next time.
This is the same homework that we got last
Yeah, just finishing that up.